Calorimetry. I don't want to go in details to explain the calorimetry. Just I want to do some application or only one application. In general, calorimetry is a device that's used to measure the amount of heat. Okay, you know we can find Q in and Q out, and also it can be used to calculate the specific heat, small c. Okay, so here we can calculate Q hot or Q cold. Also, we can calculate the specific heat C. Okay, these values. What is the principle? For an isolated system, if we have an isolated system, inside the system we have water. Okay, this is the external medium of the medium where we have the water, and inside we can put an object. Okay, in this case the water has a temperature T1 and the object has a temperature T2. T1 is not equal to T2. So as we have a difference of temperatures between the object and the water, so we must have an exchange of energy between them. Okay, we have a heat lost and a heat gained by one object. Okay, so in general we can say the heat Q lost equals to Q hot as magnitude. You have to know the energy out of one part of one medium equals to the energy into another part. We can say heat lost equals to heat gained. Okay, this is the general principle. You have to know heat lost by one object equals to heat gained by another object. We don't have an external heat come in or come out. Okay, you know, in general, Q hot must be, it's a positive value, and Q cold, it's a negative value. So the magnitude of Q hot is equal to the magnitude of Q cold. But Q hot as value equals to minus Q cold, because Q cold has a negative value. Okay, you can write the absolute value of these two quantities are equal, but without absolute, Q hot equals to minus Q cold. Okay, we will do some application, you understand better. Here, in general, how can we calculate the quantity of energy Q? Okay, anyway, we talked about this equation in the last slide. Determination of the heat energy transfer. We can say heat, only heat, or heat energy transfer. We can say the transfer of energy is the heat. To determine the amount of heat gained or lost by any medium, we have to calculate Q equals to mc delta T. Q is the heat energy lost or gained, m is the mass of the medium, C is the specific heat capacity, delta T is the change in temperature. Okay, let's say, okay, I repeat the same information, it's okay. Here we have an object, unknown object. Okay, it's a sample, unknown. I don't know the identity of this element, this one. I don't have any idea about the heat, about the specific heat. If I have the value of Cx, I can know the value of the identity of the object. We have this object of mass mx with Cx and Tx. Okay, this is the initial state of the object. We put this object in a quantity of water of m mass. C is the specific heat of the water, and T is the initial temperature of the water. Okay, you know, we have Tx is bigger than T water. For example, we have 80 and this one equals to 30. Okay, initial state. In general, at the final state, at the thermal equilibrium, we must have T final of the system. This T final, it must be between 80 and 30. You know, because the object will lose some quantity of heat, and the water will gain this quantity. So the temperature will decrease of the object and the water will increase. The final temperature will be between the highest value and the lowest value. Okay, so you know, we have the equivalence as we have an isolated system. Q hot equals to minus Q cold. We can apply directly the relation. You know, Q hot, we have Q hot and Q cold. In general, the water will gain some quantity of energy because it's relatively cold. It has 30 C. The water will gain the quantity of heat. So the water has Q hot. Okay, Q hot is the Q gained by the water. And the object will lose a quantity of heat. So we can say here Q cold is the quantity of heat lost by the object. It's very important to know which one Q hot and which one Q cold. Here you can say about the object, we have Q cold, and for the water we have Q hot. Okay, so Q cold or Q hot equals to the Q gained by the water, equals to M of the water, C of the water, times T final minus T initial. Q cold concerns the object, equals to M of the object, C of the object, and T final minus T initial. We have the same T final. Okay, in general, in the table, you have the value of C water. I give you its value. We have a known value of mass of the object and of the water. You can calculate the masses easily. Okay, we can weigh the masses of each one. For example, here, maybe I want to calculate T final, or we can calculate, for example, Cx. In general, we can calculate T final easily. We can put a thermometer inside. We can calculate T final. We have the value of T initial of the water. We have the initial value of Tx. we have T final, we have the mass of the object, so we can calculate Cx. If you calculate Cx, you can know what is the identity of this object. Okay, in this case, we can calculate C of the object if the object has only one phase. Okay, for example, the object is a solid object. Initially, it's a solid object, and finally, it's a solid object. We don't have a change of phases. We have only one phase. Also the water, we have a water initially and water finally. We don't have a change of phases between the initial state and the final state. So in the case of one phases, we use always Q equals to mc delta T. Okay? This equation is used with the for the medium of one phases. We cannot use this one if we have, for example, ice and water. In this case, we have two phases. We use only this one if we have only ice, only water, only solid, and only any object with one phase. So what I mean by phase changes. A phase change is when a substance changes from one form to another. Okay? For example, we have some quantity of liquid. Here we have ice at initial state. We give some quantity of heat. Here we have change or phase change. We get finally water. Okay? We have a phase change between the initial state and the final state. Okay? In this case, we cannot use here Q equals to mc delta T, because we have here a change phase. Okay. Two common phase changes are, in general, we have a change of phase between solid to liquid. Like in this case, we change the solid to liquid. Here we can say melting or melting. Or we can change the liquid. We have some quantity of liquid. We give a quantity of heat to the system. And finally, we get a gas. Okay? Here also we have a change of phase. So we are talking about melting from solid to liquid or boiling from liquid to gas. Okay? During a phase change, there's no change in temperature of the substances. Okay? Delta T equals to 0. When we have a change of phases between initial state and final state, T initial equals to T final. For this reason, we cannot use Q equals to mc delta T. Why? Because I give a quantity of heat to the system to melt the solid object and to transform it to the liquid state. I give the quantity of heat. If I use this relation, T initial equals to T final, in this case, Q equals to 0. In this case, it's not logic. So you have to know two important points. First of all, if we have a phase change between solid liquid, liquid gas, liquid solid, gas liquid, we have the same temperature during the phase change. T initial equals to T final. And we cannot use Q equals to MC delta T. In the next slide, I will explain which equation can you use in the case of phase change. Okay. The second point, T initial equals to T final. And okay, the second point, if you want to calculate Q, you have to use another equation.